Chemistry lessons. This lesson's on how to determine an oxidation number of an element in a compound. If we remember that each element has a specific oxidation number, it would depend on whereabouts it's at. Remember that everything here in column 1 has a 1 plus charge, because when it becomes an ion it loses its electrons. Everything in column 2 here then would have a 2 plus charge, because it will lose both of those electrons in those outer shell there, its valence electrons, if you will. And then remember that these guys over here, fluorine being the most electronegative, everything in this column has a -1 charge, and then we have a -2 and a -3. If you need to review the actual charges and how they become ions, please review the ionization video, and that will help you out. But today we're going to learn on how to determine the charge of an element inside an entire compound. So let's take a look at this one here. This one here has a polyatomic ion on it, which is the dichromate. You don't have to worry about memorizing that. And it is combined to potassium. The dichromate as an entire unit has a 2- charge. That's why there's 2 potassiums here. But what we're going to do is we're going to look at what is the oxidation number on a chromium element within this potassium dichromate compound. So the first thing we know is we have to look at the periodic table and we find the ones that are absolute. And this one here, potassium, is going to be one of those that we know for sure. It's a first column element, an alkali metal, and we know that everything in the first column has a +1 charge on it. Okay? The other thing we can be pretty sure all the time is that oxygen, well, usually always, there's a few exceptions, but for your use in this class, you can pretty much always say that oxygen has a 2- charge on it. So if you were asked what was the oxidation number of potassium, you would say +1. If you was asked what was the oxidation number on oxygen, you would say 2-. We've been asked to determine what is the oxidation number of chromium. So what we're going to look for here is this chromium right here, and we want to know what its oxidation number is. Well, what I have to do now is figure out what's the total charge on this compound. First of all, there is no charge up here, so I know I've got to get to 0 because it does not list a charge. Nice line there. Okay, so I have 7 oxygens. If each oxygen is a 2-, that gives me a total charge of a -14, excuse me. So this is a -14 I have over here for just my oxygens. On my potassiums, each potassium has a 1+ charge, and I have 2 of them, so that's going to be a 2+ charge. Since I know that I have to get to 0, I would take that -14, and then I have 2+. If I add those together, I have a -12. Okay? So I have to have a positive charge over here of 12, because if I was to say, alright, I need to get rid of that, well, a +12 would get me back to 0. 12 is my magic number here. So I need a +12 charge on these chromiums to balance it out. But if I take a look at this, I see that I have 2 chromiums. So if I take this and I divide this by 2, then I end up with 6+. So each chromium in this particular compound formula has an oxidation number of 6+. And that's how you determine the oxidation number of. Now I'm going to give you another one here, and I want you to take a little bit of time to try to figure it out. And what I'm going to give you is magnesium phosphate. And that balanced charge is then going to be 3 magnesiums 2 entire phosphates, which will give you an overall charge of 0. So press pause right now, take a few minutes to try to figure this out, and then we'll go through it. Alright, hopefully you figured it out by now. Once again, we know that everything in column 2, our magnesiums here, have a 2+ charge. So the oxidation number on magnesium is 2+. I have 3 of them, so I have a total charge of 6+. Now I come over here to the other side of what I know. I know that every one of my oxygens has a 2- charge. Now I have 2 times 4, I have 8 oxygens here. So multiplying that together, I come up with a -16 on this side over here. Once again, I have to come up to 0, so I know that if I have a 6+ on my magnesiums, a -16 on my oxygens, I got to come up with a number of 10 to balance out this -10 down here. So I'm going to have to come up with a +10 on this over here. So I know that my phosphorus has got to be, phosphorus has got to be a total of a +10, but I have 2 of them because this tells me that there's 2 of everything that's inside those parentheses. So divide that by 2, then my oxidation number of my phosphorus is a +5, and that would be the oxidation number of what we're looking for here. I need you to review this as many times as possible. This is a skill that you'll have to use in creating compound formulas, and it's also on one of the mandatory pass exams. Remember, if you ever have any questions, come in and ask. Don't sit there and try to take it on yourself. This can pile on top of you after a while, and it just gets overwhelming if you don't come in and ask questions. Always remember, Chem is try. Okay? You got to keep trying to get this going, and stay gritty out there.